Our first grouping in the plant kingdom is the non-vascular plants. These plants lack vascular tissue. What that means is they do not have xylem or phloem. And if you aren't familiar with those terms, we will define those and talk about those when we get to vascular plants. But these are tissues that effectively carry water and the sugar throughout the plant to the different cells that need it. So these plants do not have that type of tissue and system to deliver nutrients and water to cells. So these are going to be restricted in size because they're going to rely upon diffusion and osmosis to carry that out. So uh, this is going to be the case for their entire life cycle. When we get to some of the other groupings, you'll see that some may lack this tissue during parts of their life cycle, but they have it at some point in time. These never have it. Therefore, they don't have true root stems or leaves because part of the definition of root stems and leaves is that there's vascular tissue contained in those structures. Some of these non-vascular plants do have kind of a leafy appearance in that the way the cells grow, uh, they they look leafy. I have some pictures here, I think, in a slide or two that you'll see. So here's where the gametophyte is the dominant generation. And previously I had said that's not common. But here, this is the grouping of plants where the one we would recognize, if you've ever seen any of these plants before, if you do see them, the larger one, the one that lasts longer, the one you would learn to identify first would be the gametophyte generation. So here we have common names: liverwort, hornwort, and moss. So those were common names. So let's look at the phylum names because, I always want you to give me the scientific phylum name and not a common name for things. So our first one is Anthocerophyta. And the antho has something to do kind of with like antler or horn. And that's why the common name for this group is often hornworts. This is because the sporophyte stage resembles the horns of an animal in some way. You can kind of see that a little bit here with these structures in the center picture. They're going to live in damp, shady habitats, rely on osmosis and diffusion to transport nutrients. And I go through these pretty quick, really. Hepatophyta is the next one. A common name is liverworts. It's because hepato means liver, and the like hepatitis is itis means inflammation or disease of something. So hepatitis is a liver disease. So that's your hepato uh, is the root word there. So same as here. We have two body types. There's a lobed body that's referred to as a thallus. Um, Smooth on top with root-like rhizoids projecting down into the soil. Told you we'd come back to that term when we had it in fungi. We'll get even more, I think, before we're done. Okay, we get into plants with roots. Okay, root-like. There's a leafy body version. This is the most numerous of this grouping, but it's also the lesser known. This is the one that we typically see the most. That lobed body is what looks like the liver and the organ of the liver. So you may be looking at these two and seeing this word warts. Okay, W-O-R-T-S is not the same thing as W-A-R-T-S, warts, warts. W-O-R-T-S, as you see here, is an old, really old English word for plant. And I don't know what language its origin is in, if it's like Angle or Breton or what, but it's not the German. Okay, a lot of English has German and Norman. The Saxons came over from the mainland into Germany at the end, kind of at the fall of the Roman control of Britain, and then later in 1066, the Normans came in and brought a Norman French, And this word predates all of that. So it's really, really old. And so these plants, something I like to talk about in this in connection with these is that these plants, you can see a kind of lobed look. The horns here. Uh, in ancient times, people thought that if a plant resembled something, it might be good for healing that thing. So this was thought to be a good plant to treat liver disease, and this was thought to be a good plant to treat. Well, one thing was diseased horns in animals. If you had domestic livestock that horn got infected, that might help. But you have to also understand that in ancient peoples, the idea with the horn was the horn represented sexual virility or fertility. Okay, in animals where the females also have horns. So it was also applied to humans that that had something to do with sexual organs. So if you had a problem or disease of the sexual organs, this was thought to be a plant that could cure or heal that, or these plants, this grouping of these hornworts. There's more than one type of hornwort. There's more than one type of liverwort, or Anthocerophyta and Hepatophyta. So um, just wanted to point that out, that these are very old words, and these plants have been known for a very long time. They may be something you're not familiar with. They're very small and tiny, but ancient peoples knew them very well and had uses for them. Have those uses been found to be true? Not to my knowledge. Have we found anything in liverwort that is useful in fighting hepatitis, or anything here either for uh, sexual diseases? But there have been plants, and actually, if you study pharmaceuticals, you will find that the history of pharmaceuticals, almost all of our pharmaceuticals originate from a plant, or as seen in the previous kingdom, a fungi. Something natural, something biological, uh, gives us the active ingredient or the chemical for our pharmaceuticals, and then we learn how to make a synthetic version of it that's easier to make and kind of cheaper to make. And then some people contest whether it's as effective as the natural form, and that's all up to another debate that we're not going to go to here. But um, it is very likely that these plants have some use, something in there that's beneficial in some way, maybe not for what ancient peoples thought, but maybe for something different. Also, sometimes extracting out the one active ingredient out of these plants is not possible, because it's not one active ingredient. It is a combination of things that act in a kind of a symbiosis, right, with each other. You get a combination of chemicals that create an effect, and identifying exactly which combination of chemicals, so that we natural, like phytochemicals is the term for that, um, which combination we could reproduce synthetically without having to reproduce every single chemical in the entire plant, is very difficult, because you can have hundreds and you may need a combination of five, you may need a combination of 20. It may just not be one or two. And research has started finding some of these combinations. Um, but when you have that many variables, it's really, really hard to track them down in a scientific manner. Okay, so that's why you still have some people who will say that your plant remedies will work better than anything else. Okay, because they're seeing that relationship. They think they're getting the relationship of these chemicals working together, whereas the man-made synthetic versions that have the one thing extracted out don't. Now, the only example that I know of where that I've read this is the case in particular is with um, digitalis. Okay, digitalis is foxglove. It's dangerous. Don't go try this at home. Okay, uh, and if your mom or aunt or grandma planted foxglove as a kid, they probably told you stay away from that. Don't eat that flower. Don't mess with that flower. My mom wouldn't plant them around when I was a kid because she was afraid um, that me or my friends or somebody would get into them and do something stupid. But uh, I didn't have a habit of eating flowers, but anyway, she just was overcautious. The thing is that the chemical extracted out of that is used, or originally was, and now a synthetic version of that is used to um, treat heart disease. And what I read an old time doctor's account of this was he was one of those horse and buggy carries black bag around type doctors at a time when that was transitioning into doctors don't make house calls anymore. People come to the hospital or to the doctor's office at least to be treated. And his actually the account was by his one of his interns that came to work with him, and in the new office type setting. And the older doctor made a comment about how sometimes people really overreacted to the medication, and it was kind of hard to get the right dosage settled in on some people without causing sometimes some severe issues. Um, and this was, a long time ago, so we probably got better at that. But in that transition time period, there was the old doctor was noticing some differences or some difficulties. And what he told the intern that stuck with the intern was that people didn't used to have really bad reactions to overdosing. If you got the dose too high, they just got nausea and got sick, and then you need to back it off. So the intern kept that in his mind. And later, when he got into doing some medical research, he looked into digitalis, and he uh, found that there are other chemicals in the foxglove that do cause nausea. And typically, if you don't just take in a whole huge amount of this stuff, if you're taking small increment doses, lined out by a doctor, the of the whole plant. Okay, that's what the old doctor was using. They were using a whole plant derivative. Um, you get enough of these chemicals to cause you nausea a long time before you get too much of the active ingredient that can actually kill in overdose quantities. So um, again, that's an example of how things work together. That one's not so much the combined effect increased the effect of the drug to be better. It was one was a safeguard against too much of the other. And apparently the different amounts that make people nauseous are a little bit different for different people. And that kind of was an indicator on how much of the more dangerous active ingredient they needed. So I thought that was really interesting when I read that. Uh, I've only found that referred to in that one source. So uh, usually we like to find things in multiple sources in science, but I thought I would relate that because there isn't a lot of research sometimes done into the plant combinations because the funding's not there, because um, there's no way to patent a naturally occurring substance. And a lot of our research is funded by companies that hope to get a patent on the chemicals that they identify and they can make a synthetic version of and then patent that synthetic version. And then they're going to get a return on the investment, the amount of money that they spent researching it. Because research is expensive. The equipment's expensive. It's it's expensive, and it's a limiting factor on research. And with natural products, you can't patent anything, so the amount of money you're going to get back into selling a product is limited, so the research is limited. That and a lot of our medical people don't are taught, okay, that it's not effective. Okay. Um, I will not ask you about this. Just like in the FinCI, we're going to skip over this because we have um, a short amount of time here. We've got difficulties and distance and all of that. Last phylum, I'm sorry, yeah, the last phylum in this grouping of non-vascular plants is the Bryophyta. These are your true mosses. We call a lot of other things mosses, but only things in this phylum are actually mosses. And we find them everywhere. They can range from the tropics to the Antarctic to deserts to bogs. So we got hot, cold, dry, wet. Yeah, they can be anywhere. They do need water to live, but some of them have a unique ability to just store water or dry out until the rain comes again. Um, my next slide. No, I don't. Okay. I don't have that specifically mentioned. The dry out one is kind of interesting. It's a desert plant. Actually, I think there's several different varieties of this. The one I'm familiar with is one called Selaginella. Common name for that is resurrection plant. And it will just dry out and wait until the next rain comes along, and then it'll come back to life. That's the name resurrection plant. It is, I used to work in a flower shop. You're going to find that out here in this, as my high school job was a flower shop after school and weekends. So the Selaginella is a plant that was recommended for people who forgot to water their plants and couldn't keep a plant alive. Okay, people who could, I can even kill a cactus type people, because this is one that could just go dormant basically, and then come back to life. Desert plant. Another cool thing about mosses is that you can fragment them, and then any fragment, any piece of that original moss can start a whole nother plant. And I learned this watching This Old House way back in the day when I was in high school. There was a colonial mansion, somewhere back east. I don't remember where it was. And the place had had a rock wall out near the road. And of course, over the hundreds of years, that road turned into a highway. And at some point, a big truck had smashed into part of the wall and just broke it out. When This Old House was there remodeling, redoing, renovating, restoring, actually, and they restored the original uh, plantation house, they asked the owners about this rock wall. Said, "Don't you want us to fix that?" And they're kind of like, "Well, no, because we looked into that once, and if we put new rock in there, the wall's going to look patched, and we thought it was just better to let it be like ruins and all kind of old looking than to have this patched spot in there." But the people at This Old House said that they could kind of fix that. So what they did is they went, and having a good budget at that time, they opened up the quarry, the old quarry where these rocks had originally been quarried out of, which wasn't that far away, um, and got the same type of rock out. Of course, newly quarried rock looks new. So it did look newer than the old rock that was there, but they got the same type of rock, so it would be the same in that. And then they took some moss that was growing in a shady spot on another part of the wall, and they put it in a blender. And that was what fascinated me the most about this. They put it in a blender in water, blended it up, put it in a sprayer, and just sprayed the new section of wall down with this moss water mixture. And then the cameras came back sometime later and showed us what had happened. The moss had grown on the wall. Uh, I believe they did go mist the wall down every so often to keep it damp so the moss could grow there. Eventually, they could let the moss die off the section, but what the moss was doing was the moss was aging the rock. And that's one of the things that mosses do. I mentioned pioneer species when we were talking about lichens, and here I'm going to go into greater detail with that a little bit. So, pioneer species are one of the early, if not the first, species to move into an area after a major ecological disturbance, such as an earthquake, volcano, fire, etc., or in this case, bare rocks that have been replaced in a damaged wall. They can grow on bare rocks. Our lichens can grow on bare rocks. Our mosses can grow on bare rocks. And so what they do is they help convert the rocks to soil. They exude out waste products that are chemicals that add to the breaking down of the rock. Rainwater comes along, and you have the physical factors of the water freezing into little tiny crevices and holes in the rock and kind of expanding that, because water expands when it freezes. So that puts pressure on that stuff to break it, widen the crevices. And then you've got the chemical activity of these exudates that dissolve the rock minerals. And then when they die, they stay there. They fall into these crevices and into these little pockets, and they build the pockets up over time. And organic matter decaying mixed with mineral matter is soil. So I think a volcano is probably one of the most dramatic examples of this. You've got a place where you have vegetation, everything's fine, and suddenly this volcano erupts and deposits lava everywhere, which hardens into lava rock. Now everything's covered in this bare rock, and it's infertile. Nothing can really grow there except these things. Pioneer species can come in, start growing on that rock, breaking it down, and over thousands and thousands, hundreds of thousands of years, that volcanic area will become a very fertile soil because brand spanking new minerals basically were thrown up out of the earth and covered the land that was there, which may have been exposed for a very long time, may have grown vegetation for a very long time, and may have been pretty much getting depleted of nutrients that those plants needed. So now here we've got a whole new start over. And I think that's kind of a fascinating thing to look at. It's very long term, time wise, but it's recycling. It's the Earth's recycling itself. Kind of cool. We find mosses growing in bogs, as I said earlier. They don't decay when they die there because bogs are acidic, and the decaying of these things, these organic matter uh, sources, they will create this acidic environment. This is very has become very useful to archaeologists because we can find well, scientists, I lump myself in that group. I'm interested in archaeology. I have never done any archaeology. I have no experience in it, but uh, I read about it. That's all. And I'm fascinated again by that. But historians, archaeologists have found some uh, really informative burial sites or artifacts, goods buried in bogs. Looks like they used to bury people in bogs. There's some indication that maybe some bogs were considered to be holy, or at least gateways to the next world, the underworld, the afterlife, and that sacrifices were made by throwing objects out into the bog, or maybe taking them out there and leaving them in if they were thrown. But I read somewhere they thought they were thrown out into one of the bogs. I guess that's kind of maybe it would have been hard to traverse out into. Uh, and so we're finding these very well preserved pieces of textiles and leather goods, the things that would normally have decayed in all the thousands of years since they were deposited there. But the acid has kept them preserved, kind of pickled, if you would. So that's very useful for us today in studying history and trying to figure out ancient humans and prehistoric humans and what they did, how they lived, things like that. Sphagnum peat moss is um, used for fuel. Particularly, this is well-known use of in Ireland as a fuel for Ireland. Uh, they chop it out of the ground in kind of squares and dry it, and they burn it a lot like we would wood. It also is used to help improve water holding capacity of garden soil. So I live on a hill that it's just clay and rock. When it's wet, it's way too wet, and when it's dry, it's like concrete. And so when I want to dig a new flower bed, and occasionally even in my older beds, I have to go get some peat moss and mix it in there because otherwise clay will hold on to water, but it holds on to it in such a way that it doesn't let go for the plant roots to take it up. And then when it dries up, it's just like I said, like concrete. It's really solid, and it's just not really conducive for a lot of things to grow in. So I have to amend my soil, and this is common. A lot of gardeners will do this if their soil is not ideal, and sphagnum's uh, in high demand for that. Uh, Ireland was exporting it. I read a number of years back they were exporting it at such a high volume that the government began to fear that the poorer people who rely on it for fuel wouldn't have enough to get them through the winter. So they put a limit on how much could be exported. And so I'm told today we get most of ours from Canada, and that they also have the peat bogs up in Canada. So it's typically northern, damp, northern climate areas where you find the peat, or sphagnum is the proper name for it. And that's where we will end this presentation with the non-vascular plants, and we'll come back and talk about non-vasculars next.